This is Module 2, Section 5, Wires and Terminals Connections. 5.1.1, Insulation Damage. Insulation shall not have cuts, breaks, cracks, or splits. They shall not be melted into the wire strands. They shall not have its thickness reduced by greater than 20%. They shall not have ragged pieces of insulation that are greater than 50% of the insulation diameter, or 1 millimeter, whichever is larger. Now, also shall not be charred or burnt. Slight discoloration is acceptable. That happens sometimes when you're using thermal tools like soldering irons or thermal strippers or heat guns. A slight discoloration that could come off is acceptable. Something like this, though, that is just straight up burnt, that's not going to be acceptable. Chemical insulation stripping agents shall be used only for solid wire. So you'll see in this little cartoon here, it shows the chemical agent, how that would kind of work, but you'll notice that it's only for solid wire. It cannot be used on stranded wire. That chemical agent would kind of get sucked up into those strands, and it would start to corrode the wire it would go under the insulation and would corrode the wire from the inside. Chemical solutions, paste, or creams used to strip solid wire shall be neutralized or removed prior to soldering. Strand damage, so 5.1.2. Strand damage shall not exceed the table limits of 5.1, which is on the next slide. Strand damage that does not exceed the limits of table 5.1 shall be considered a process indicator. Strand damage is not going to be in acceptable condition. It's either a process indicator or a defect. It depends on this table here. Shall be no bird caging greater than 1 strand diameter, no bird caging beyond the insulation diameter, and strands shall not be cut to fit. This is table 5.1. Your number of strands here, your first column on the left, your maximum allowable strands that can be scraped, nicked, or severed for class 1 and 2 is your second column, and your 2 columns over here on the right are both for class 3, but it just depends on if the insulation or if the wires are going to be tinned before installation. Okay, can I get my pen to work? I don't know if my pen's not working. Shoot. Okay. Tinning of stranded wire forming. So stranded wires shall be tinned when they will be formed, spliced with the exception of mesh splices. And if they are put into a solder sleeve, that is optional. Typically, whenever you're using a solder preformed, like a solder sleeve that's been actually assembled at a manufacturer, they're already tinned on the inside. Stranded wire shall not be tinned when used in crimps, threaded fasteners, or for forming mesh splices. Crimps and fasteners, the wire needs to be a little bit more pliable to be able to go into that crimp without breaking the wire or breaking the contact. Same with the fastener, it needs to be able to go around like that hardware. It needs to be, screwed in or bolted in. It needs to have a little bit of give to it. With the mesh splice, those strands need to be separated, and it's kind of hard to separate a wire when it's been converted into a solid piece of metal. You can try, but I don't know if you're going to have much luck with it. Wicking. Wicking is when solder goes up underneath the insulation. It gets sucked in through the strands and goes underneath the insulation and cools there. So basically you just have this piece of solid wire underneath here. That's not flexible, it's metal, it's not going to bend. Wicking shall not extend into an area that is required to remain flexible. So this right here, this picture right here, shows us what a good, nice wetted wire is. See, will this blow up? No, it won't. Okay. So this is a wetted wire. You'll see that the solder is nice and shiny, but you can still see the individual strands. This is a properly tinned wire. Now, non-wetting, what non-wetting looks like, you'll see that the solder hasn't flowed. It hasn't gone down into those strands. It almost looks like it's floating a little bit on top. Also buildup. If you do have solder buildup, it shall not affect the subsequent assembly steps. This is probably one of the easiest fixtures you'll have. If you have a little blob of solder on your wire. You just heat that up with your soldering iron and just kind of take it to the end of the wire. Just kind of drag it to the end of the wire and it'll come right off. So this is a single jaw mechanical stripper. You will hear me refer to these as alligator strippers. You do have some of these in your toolbox. I do not recommend them myself because it's really easy to nick your wire doing that. What we have is the double jawed strippers, which is what I recommend. However, this person's using them in kind of a way that I don't really understand because they're not using the strippers as much as they could be. So they're still stripping it just to cut the wire base, cut the insulation, and then stripping it off by hand. You can take off the whole wire insulation with your strippers if you're using them properly. This is thermal wire stripping. We don't use one of these in our class. They are used in the wire harness class. This is for more like for coax or shielded wire. But you'll see that it just kind of melts through the insulation and just takes it right off. So tinning with the soldering iron. We will be doing this on all of our wires that we connect to terminals. This is one of the nicer methods I've seen. So put a drop of solder on your soldering iron, put the soldering iron underneath your wire, and then feed it the solder on top of it, and then just drag it along. Nice and slow. You can use a drop of flux. In fact, I recommend you use a drop of flux on your wire. And we're going to watch that again. So drop a solder on the iron. So solder on top, iron on bottom, and just drag it along. One smooth motion. Don't stop. Just one smooth motion. And it'll wet and it'll tin your wire. This is a soldering pot. Our solder pot needs to be replaced, so we don't need to use one. We are not going to be using one of those in our class right now. But that is satisfying to scrape off the top. I will say that. So satisfying. So just that quick. It's just basically just a little pool of solder there, and you just dip your wire in there. Okay, terminals and solder cups shall not be modified to accept oversized conductors. If you have to modify your wires or your components, you have either the wrong wires, the wrong components, or the wrong engineering. Section 5.3, bifurcated turret and slotted terminal installation. This is a bifurcated terminal. It looks like a goalpost or a tuning fork. You want to wrap the wire around the post, flush against the base. So it rests on the base and it wraps around the post. The base is what is seated against the board. When we solder these in class, we just solder the terminals. We don't do any kind of board installation, so you don't have to worry about all that. So I'll actually go through that part. It does talk about that a little bit in this module. I'll kind of skim over that a little bit. This is a turret. So again, you want to rest your wire against the base and wrap it around the post. If there is shank damage, so the part that goes inside the board, a circumferential crack is a crack that goes around the circle part of the shank. The shank shall not have those kinds of cracks, and it shall not be perforated, split, cracked, or otherwise damaged to the extent that any kind of fluids or any other kind of FOD can get in there. The flange, so it's that bottom part here. This is the flange. The flange, when it's rolled up or mechanically like split out to kind of secure it, the flange shall be free of missing pieces and circumferential splits. The flange shall have no more than 3 radial splits if they are separated by at least 90 degrees. So if you have 3 splits that are evenly spaced, they're going to be 120 degrees apart. That would be acceptable. So this top one is actually acceptable because they are greater than 90 degrees. So 90 degrees, look at a clock. 90 degrees is between 12 and 3. That distance right there is 90 degrees. These are from like 12 to about 4 o'clock, which would be 120 degrees. The flange shall not be damaged to the extent that liquid substances can become entrapped. Your flared flanges should be formed to include an angle of between 35 and 120 degrees. and it should not exceed the diameter of the land, so it shouldn't like roll over and off the land. Terminals that are not connected to a board circuitry shall have a rolled flange, and a foil flange shall not be used for a rolled flange unless it is electrically isolated. So that's the difference between an electrical and a mechanical. So electrical is when they're flanged. Terminals shall be mounted with flared flanges if there is land or ground plane on the flared side. Terminals shall not be flared to the base material of the printed board. If it needs to be flared to the base material of the printed board, then it needs to be a rolled flange. So for soldering of that flange, whether it was the flange or whether it's the rolled or flared, if it is to be soldered, the circumferential fillet and wetting should be on the solder source side, 270 degrees for class 1 and 2, and 330 degrees for class 3. So again, let's go back to the clock. 270 degrees is between 12 and 9. Okay, that's 3/4 of it. 330 degrees is between 12 and 11. So all the way around, you have that one little sliver between 11 and 12. That's 30 degrees. So that's basically almost all of it, right? Percentage of the solder source land area, so where it's being soldered to, covered with wetted solder, needs to be 75%, at least 75%. Okay, so now we're at section 5.4.1.1, that is insulation clearance. For minimum clearance, the insulation shall not be embedded in the solder, shall not interfere with connection, and should not obscure the contour. Maximum clearance is that it shall be no more than 2 diameters or 1.5 millimeters, whichever is larger. When service loops are required, so we're on section 5.4.1.2, service loops. When service loops are required, that's your main key word there, when they're required. Wires shall allow for at least one field retermination. When service loops are required, that requirement should be included on engineering documentation. So this wire number 1 here has a service loop. See how it's looser, it's a little more lax, it has more room. So if this does need to be reterminated in the field, it can be cut, trimmed, and reterminated without losing any slack in the wire. Number 2 is just the right length. It cannot go any shorter. If that needed to be cut and trimmed and reterminated in the field after it's already been put in use, you would have to replace that wire. Stress relief. If you are dealing with components, at least one component lead shall have stress relief if the component is not secured. If it is secured with adhesive or clips, like this bottom picture, all leads shall have stress relief. If there are wires connected to terminals, they shall also have stress relief. When we are wrapping wires, they may be wrapped counterclockwise or clockwise, consistent with the direction of the potential stress application. So you should come in from the side the way and then just kind of wrap it around naturally. You don't want to wrap it and then kind of go back the other way. The wire shall continue the curvature of the dress wire. So see how like this one goes down into like a little J. And then this one just kind of rolls around like this. So if like this one, if it's coming to the right, you don't want to have to go over here to the left and then wrap it around that way. You can just keep going around in a nice little curve. That's what you, that's the shell there. Insulation sleeving, don't even worry about this math right here. There shall be no damage to the sleeving. It shall fit snugly to extend over the wire insulation, a minimum of 2 wire diameters. There is some algebra here that I'm not going to bother you with. But yeah, just remember it's minimum of 2 wire diameters. And if you have questions about that, if you see that on your test and you have questions about that, by all means ask me. Because I know that there's a question on the test that I've seen that's worded a little weird for this one. But just remember that it needs to be at least a minimum of 2 wire diameters. Lead and wire end extensions. Lead and wire ends should not extend more than 1 conductor diameter. This right here would actually be a defect. Even though that's a should, It's considered a defect because it is violating minimum electrical clearance. That is way too close to this other post here. This would actually be considered a defect. Wire and lead wraparound shall meet the requirements of Table 5.3. This is Table 5.3. You'll see that it's kind of hard to meet Class 3. So basically it has to be greater than 180 degree contact between lead or wire and the post to be acceptable for Class 3. Everything else is a defect. As the exception to Table 5.3, this is Table 5.3 right here. Table 5.4 is with wires that are wire gauge 30 or smaller. And remember that if the wire gauge, the higher the number of the wire gauge, the smaller the wire. So a 30 gauge wire is smaller than a 26 gauge wire. These are very thin wires indeed. So they do have a few more, they have a little bit tighter wrap requirements. Really with Class 3, the only thing to be acceptable has to be greater than 300, equal to or greater than 360 degree wrap. So this over wrap here that this is showing, that is what's acceptable. That's acceptable for 30 gauge wires or smaller. A side wrap connection. Largest wires should be on the bottom and wire ends may extend beyond the base. Just remember, it cannot violate clearance. The wires shall be parallel and shall be dressed through the slot. Do not try to be cool and wrap them around both slots or wrap them in a weird S shape. You don't need to do that. It just goes around one. Shall contact at least one corner of the post and shall meet the requirements of Table 5. Table 5.5, it just says, is it 90 degrees or greater? Yes or no. And if it is greater than 90 degrees, then it's acceptable. If it's not, it's a defect. And that's for all three classes. Side wrap connection, 5.4.3.1. Wires may be routed straight through when documentation specifies staking to the requirements of Table 5.6. What Table 5.6 in our book shows us, but I can just go through it real quick. This where it says the 0.75 millimeters, and then says Note 1. Note 1 says AWG 22 degrees or smaller. So that's 22 degrees. 22 gauge, 24 gauge, 26 gauge, 30 gauge. For wires that small, it would be a defect if not staked. For wires 20 gauge or larger, so 20 gauge, 18 gauge, 12 gauge, 16 gauge, it would be A1P2D3 if not staked. I'm telling you that this way because you may see a question on the test that asks you about, I think it's 22 gauge. I think it's 22 gauge that they ask about. Maybe it's 18 gauge. I can't remember now, but there you may see a question about that in your test. Okay, so top and bottom route connections. The insulation enters the shank. That is a defect for Class 3. Wire insulation shall not enter the shank area of terminal. That is A1P2D3. Top routed wire shall feed straight into the terminal post, and the remaining space of the post shall be filled by a wire filler or the wire being bent and double. That again is also an A1P2D3 if this condition is not met. Slotted terminals shall be terminated with the wire straight through. They shall not extend over the top of the post, and the wire end shall be discernible on the exit side of the terminal. You need to make sure that your wire's gone all the way through. The only way to really tell that is if you can see the wire on the other side. Hook terminals shall meet the table's requirements of 5.8. For the purposes of our class, when it says the base, less than 2 wire diameters from the base, I go straight across here, so like a rainbow. So from here over to here, that is where I want to see your termination. Just in that top of that hook, make it like a rainbow. That's where I want to see your termination. Pierced or perforated terminals. Basically, do they pass through the eye? Yes or no? And does it contact at least 2 surfaces? Yes or no? This picture right here, the one where the wire is going through from like a top bird's eye view and it's not wrapped around, this is actually acceptable. I hate it, but it's acceptable because it does touch two surfaces. This corner here on the lower right hand and this corner right here in the upper right hand. Those are considered two surface contact points. That is totally acceptable. Please don't do that. Cup and hollow cylindrical terminals. The wires shall be inserted for the full depth of the terminal, shall not be outside the cup, and the wires shall be in contact with the back wall of the cup. Now, something I want to point out to you, in case you don't have your book open, you probably should, but in case you don't, where are we at, 5.4.7? The wire or wires shall be inserted for full depth of cup. That is N1P2D3. That is only a defect for class 3 if that's not met. The wire strands shall not be outside the cup. That is a defect for all three classes. Now this one is one of the few instances you'll see in the J standard where this is not a defect. It is a process indicator for class 2 and 3. It's acceptable for class 1. This one right here, the wire or wires shall be in contact with the back wall of the cup. It's actually A1P2P3. So if you're soldering and you don't have your wire against the back of the cup, as long as you don't have strands like poking out or it's falling off, it's actually not a defect. It's a process indicator. It's, this is okay this time, don't do it again. Knock it off. So yes, so this bottom one right here, A1, P2, P3. Series connected is when a continuous solid wire, like a bus wire, may be run from terminal to terminal if 3 or more turret, bifurcated, pierced, or hooked terminals are to be connected. Curvature shall be included in the wire portion to provide relief of tension, and the connections for the first and last terminals shall meet the required wrap for individual terminals. That would be a defect for all three classes if that is not met. So section 5.5, soldering to terminals. Wires with greater than or equal to 180-degree wraps shall have wetting for at least 75% of the minimum required area. Again, that is 3/4. That is 12 o'clock to 9 o'clock. Wraps less than 180, so less than halfway, shall have wetting for 100% of the contact area. And solder depression at the wire, so where it's kind of lowers down here, at the wire and post shall conform to table 510. For top routed wires in bifurcated terminals, solder shall wet at least 75% of the height of the terminal post. I would say that the ones here on the all the way to the right and all the way to the left are at least 75%, maybe 80, maybe even a little bit more. The one in the center, that is barely 75%. You see it's a little bit lower. That's hitting that edge of 75%. Slotted terminal, remember the solder, the wire needs to go all the way through but does not go above the top of the terminal. Solder shall wet 100% of the portion of the lead or wire contacting the terminal, and solder may fill the slot. For cup or hollow cylindrical terminals, fillet shall be formed along the surfaces of the contact, and solder shall fill the cup. There is buildup that is allowed, if not even expected, that can go along around the edges of the lip or around the back. If that is okay, as long as it does not affect fit, form, or function. Solder shall wet the entire inside. It shall be visible in the inspection hole if there is one, and it shall fill the solder from the lip to the top of at least 75%. That is the one I think most people have problems with. They don't put enough solder in. They're a little tricky at first, but after a while you do get used to them. You know how much solder to put in. This next slide right here, not this one, but the next one, shows how to do a solder cup. It's actually a very good video. Now, this video is done in real time. It doesn't take very long to solder one of these. It really doesn't, once you get used to it. Want to watch that again? A little bit of solder there to create a solder bridge. So put that solder there, touch it real quickly, put the soldering iron, get it to melt, pull that solder away, keep the iron there. You'll see that solder is flowing. You feed it in the other side. There is also flux applied here. That's what's bubbling. That is flux. It does help solder flow. Now this one, the solder cup, I love this video. What they're going to show here is a really neat trick to know exactly how long your wire needs to be. So they're putting in a piece of solder here and they're bending it over the back. And that's giving you a template. Now you know how long that wire is going to need to be. It's such a neat trick. So then you can trim your wire, your already tinned wire. And then what they're doing here, what that was, keeps doing this to me whenever I try to play this video. I'm going to watch that again. So they're using the solder as a template, a size guide, if you will. And they're taking two pieces of solder and they're braiding them, twisting them together. Filling that cup and then sliding that down in there. Now, one thing I don't like about this video is that it doesn't show the tinning process. When you are doing gold removal, you really should tin the cup, remove that solder, and then tin it again, remove the solder, and then fill it a third time. And then it will be, you will make sure that all of your gold embrittlement issues are going to be handled, because you won't have the gold there because it's been tinned over. That video does not show the tinning process. It's one thing about that video that bothers me. But other than that, it's a great video. Okay, that is it for Module 2. I'm going to go over these questions real quick. So, I'm sorry, not Module 2. Yeah, Module 2, Section 5. Just real quick with these questions. A wire end that extends 1.5 wire diameters past the terminal base for Class 2 product and does not violate minimum electrical spacing. Now, we talked about the wire end extending past terminal base. Now, that's a should requirement. That's not a shall, it's a should. So you may be tempted to say no requirement established. But that's not it, because this is two different conditions. First, about your wire end extending 1.5 wire diameters, and also does not violate minimum electrical clearance. Even though this first part is a should, so it's not necessarily a requirement because it's just a suggestion, the violating minimal electrical clearance is a requirement, that it does not do that. So since it does not do that, that is considered acceptable. Because even though two conditions were called out, one of them was not something that could be deemed quote-unquote acceptable because it's just a should. Since the other one is a shall, then the whole thing is acceptable, if that makes any sense. A wire that does not allow for at least one field retermination when service loops are not required. When they're not required, they're not required. Totally acceptable. As long as you can terminate it, as long as there's no service loops required, it's acceptable. An 18 gauge straight through wire on a bifurcated terminal. This is what I was talking about earlier with that one table about the 0.75 millimeters greater or less than. Straight through wire bifurcated terminal that is not staked is acceptable. If that was a 24 gauge wire, that would be a defect. It would be a defect for all three classes. On a bottom route termination of a bifurcated terminal, the wire insulation enters the shank. Now, I know that this is a defect for Class 3. So which is the answer? I know it's a defect for Class 3, but I can't remember, like, oh, you know what, I didn't see it in the book. But I know in the slideshow it says it's a defect for Class 3. That's a really easy one to find. There's only one answer that has defect for Class 3 as the answer. It's D. A wire terminated with a 90-degree wrap on a slotted terminal. It's a slotted terminal, it goes straight through. You cannot have it wrapped for a Class 3. So we know it's either C or D, but it is not a defect for Class 1. I don't know why you're wrapping against a slotted terminal, but it's acceptable actually for class 1. So that is C. Okay, that is it. That is it for this module. This was a really short one. It also didn't hurt that I've talked really fast through it. When we are doing our test, you may come into the classroom or you may take it virtually. Just remember that when you do take it virtually, you do not have as easy an access to the resource of your professor as close by as when you are in